Okay, check, check. Can you hear me? Can you see me?
Yes.
Yeah.
Confirmed.
Yep.
Okay, today's lesson will be about types and kinds of numbers. But are there follow-up questions from last week?
Teacher, last week we covered handwriting styles for numbers 4 and 7. 4 can have an open top or a closed top. 7 has a slash or no slash. My question is similar, but for the number 0, there is, teacher, could I use the whiteboard?
Oh, yeah, sure. Let me turn on sharing privileges for you and go ahead.
Thank you. I know a 0 can be written like this or like this as a slashed 0 so that coder tools don't confuse it with the letter O. But I also saw this character, and through context, it seemed not to mean the number 0.
Yeah, absolutely right. The circle with a backslash is not 0. It is a symbol for prohibited. It's like no smoking or no parking. It's an instruction and it has nothing to do with the number 0. So the way that we write that with the, oh, no, wait. It does mean 0 sometimes. There's some languages where the / circle is a letter of those alphabets. It was like Swedish or Norwegian or something. I can't remember. So just like in English, where we use a / to stop a 0 from being confused for one of our letters, in those languages, people use a backslash to stop 0 from being confused for one of their letters. Yeah, Noah, you had a question? Okay, this one is math, but it's not 0. It's called theta. It's used in geometry, and it's a placeholder for an angle measurement.
What about this one? The lines go outside of the circle. Is this 0 or not?
This is actually a character for an aspect of set theory. It's called the null set. That may be above what we're ready for. I mean, it's already hard enough to tell the difference between lines on a screen and handwriting compared to the abstraction of the number 0. But that's like an abstraction of an abstraction. But it does lead me to my first point. Let's talk about how humans grow into using abstractions. So let me clear the screen. Okay, according to there's Piaget's developmental psychology. There's 4 stages to understanding abstraction. Now I'm simplifying this a lot, but hang on. First one is physical to physical. This is how babies learn. There is this real world thing, and they use it to learn about real world things. This is why babies are always shoving things into their mouth. They have this wooden block and they cram it into their mouth. They're using their mouth to learn about the block. They're using a physical thing to learn about a physical thing.
So the baby is not thinking, this is a cube. They're just thinking, this is hard, smooth, and tastes like wood.
Yeah, exactly. It's pure sensory input, no abstraction required at all. But as humans grow, we hit the next stage, physical to abstract. So here, okay, using physical things to learn about abstractions. This is what we did in class last week. 5 apples are used to understand the abstract idea of 5. A 5-story building, and you take away the building. We use that to understand the idea of 5. You look at the physical world and use that to extract out the concept.
Is this why children count on their fingers? Just plain counting is an abstraction, and children are not to that stage yet. They need the fingers as a physical thing in order to do the counting.
Yeah, spot on, Alan. Your fingers are the physical anchor, and the resulting total is the abstract number. Now, third stage, abstract to physical. Here, okay. This means using abstractions or models to learn about the real world. At this age, this is where kids start making a lot of science fair projects. If you want to learn about a volcano, you don't take a field trip to a real volcano. I mean, that would be dangerous. Instead, students build a model of a volcano and use the model to learn about real physical volcanoes.
Wait, isn't a baking soda volcano still a physical object?
It's physical, yes, but conceptually, it's an abstraction. The paper mache cone isn't a tectonic plate, it's a structural representation. It's a simulation. It's designed to teach you how gas pressures escape a chamber in real life. It's using a conceptual tool to understand reality. And that finally brings us to the fourth stage, abstract to abstract. Here, using ideas to learn about other ideas. This is where high-level concepts come in, and students learn about reasoning and pure logic. At this stage, you don't need blocks, you don't need apples, you don't need volcano models. You're manipulating pure ideas with other pure ideas. Is everyone with me so far?
We are still a bit lost on that last one. Could you give an example?
Yeah, an example would be literature. Students don't start to study literature until they're older. An example would be George Orwell's Animal Farm. That's already an abstraction. I mean, talking animals don't actually exist.
Hey!
But we use that. Doug, I apologize. Talking animals don't exist in my multiverse. What I meant is that children reading Animal Farm, if they read it too early, they won't understand the themes of misplaced altruism or naivety of the working class. They can't yet take the abstraction of a fictional novel to study the abstraction of political corruption. Does that clear things up, Alan?
It's still hard for us to understand. We're a hive mind and never went through those kinds of growing stages. We've always been like this, but we think we get it.
Okay, that's going to have to do for now. Anyway, the next part I should go over is a touch of history. Around the middle of the 1900s, two things happened. First, research mathematicians started to notice something. There was math for geometry, there was math for arithmetic, there was math for calculus. And when we looked deep into the foundations, mathematicians began to notice similarities. Geometry, arithmetic, all the other math disciplines, they're already abstractions. But the mathematicians were discovering abstractions of abstractions. Now, the second thing that happened is that there was a technological revolution. Rocketry, the atomic age. Politicians were worried that students are going to be falling behind and they're not being prepared for the modern world. This is where the mistake comes in. Politicians saw that the cutting edge math was abstractions of abstractions. So they assumed this is what the modern world needed. And they titled it New Math and declared that this should be the way students learn math from now on. I mean, after all, it's modern. But what politicians didn't account for is that a student that is still at the stage 2 learning, they're using real world to learn about abstractions. Those simply are not prepared for the upper stage 4 learning on abstractions to learn abstractions. Now, the biggest one of these, and why I mention new math at all, is cardinal and ordinal.
Oh, I learned about this already. Cardinal and ordinal are the two properties of numbers.
Oh, no, not at all. Cardinal and ordinal, those are properties of the Zermelo-Fraenkel set theory. They're properties of this abstraction of an abstraction that the mathematicians discovered. Numbers themselves, they have a lot more properties than that.
Illogical. Cardinal and ordinal are the only properties that exist.
Okay, they're not. So Robert, let's start with the easiest one, nominal numbers. So nominal. Okay. When this new math was being forced onto students, it caused massive amounts of confusion in everyday scenarios. As an example, think about basketball players. If you have a player that's wearing jersey number 5 and another player wearing jersey number 7, new math students were getting confused, and they thought that player 7 must be bigger or greater than player number 7. They were so drilled in on set theory that that was the only thing that they could think of.
But a jersey number is just a label.
Yeah, exactly, Alan. It's a name. That's what nominal number is. Nominal name. Names are absolutely a property of numbers, but it's a property that is neither cardinal nor ordinal. It's using a number as a name. It doesn't let you multiply the players together. I mean, like player 7 multiplied by player 5 is player 35. And it doesn't mean that player 7 is bigger than player 5. In fact, because of the new math disaster, some modern school curricula, they've actually started explicitly teaching nominal numbers to kids just to fix that confusion.
Okay, so there is cardinal, ordinal, and nominal. But surely, that is the full list of the properties of numbers.
Oh, not even close. We're just getting started. Um, let's examine a strange sentence. The sentence is, more people have eaten sushi than I have.
What's so strange about that? It seems reasonable.
Okay, then what does it mean?
Well, we have never eaten sushi, but let's just say it's a typical person. How many times would a normal person eat sushi? That may be about 40 or 50, but compare that to the number of times someone in the world has eaten sushi. The top record holder may have eaten sushi thousands of times, maybe even tens of thousands. And if 40 is less than the number of times that person has, oh, wait, no. It's not the number of times a person has eaten sushi. It's the number of people in the world that have eaten sushi. So that's millions. Compare that to just one person. Millions is bigger than one. That's not right either. It's the number of times the... Hold on, this doesn't make any sense.
Yeah, gotcha. So number of times I ate sushi is a cardinal number. Let's do that. And the number of people that ate sushi is a cardinal number. Like that. Okay. But because we can't compare them with the greater than operator, they must be different kinds of cardinal.
This sure seems like floors in a building. If I walk up 2 flights and walk up 3 flights, that's 5. And if I'm on floor 2 and walk up 3 flights, that's also 5. But if I'm on floor 2 and also on floor 3, that doesn't mean I'm somehow on floor 5. I can't add 2 and 3 in that way. So floor 2 and floor 3 are cardinal numbers, but they're not the same kind.
Well, almost, Doug, but don't forget we have words like first floor and second floor. First and second are ordinals.
Teacher, if there is more than one kind of cardinal, does that mean there's more than one kind of ordinal?
Oh, yeah, absolutely. Think about how we describe making a database. I can say, first, create the database fields. And second, add data to the fields. That sentence works exactly the same way if I swap the words first for firstly. Firstly, create the database fields. Secondly, add data to the fields.
But those are actually 2 different flavors. Both first and firstly seem exactly the same thing. So they aren't really different.
Okay, they feel the same because first can pull double duty. But compared to the sentence, the first database is for student records, and the second database is for course grades. You absolutely cannot say the firstly database is for student records and the secondly database is for course grades.
Illogical. It cannot happen that first and firstly mean the same thing, and also do not mean the same thing. Either they are the same or not the same.
Okay, Robert, you're thinking numbers are math. This is language rather than math. And in language, we absolutely can have one word mean different things depending on context.
Yeah, it's like first is a shapeshifter. Sometimes it acts like a physical pointer, and sometimes it acts like a step-by-step instruction manual.
Yeah, exactly. In English, some context means first and firstly are both the same kind of ordinal. But in other contexts, first and firstly are different kinds of ordinals. And it's that other context that shows that there's more than one kind of ordinal.
This is really opening up new possibilities. But back to nominal numbers. If nominal numbers are a third property of numbers that is outside of just cardinal and ordinal, are there more categories? Like a fourth property of numbers. Something that's not cardinal, not ordinal, and not nominal.
Yeah, there sure is. It basically goes on forever. There's no limit to the properties of numbers. Remember, cardinal and ordinal are just properties inside of Zermelo-Fraenkel set theory. They're not properties of numbers directly. Another easy category to think of is collective numbers. Let's add that in. Collective numbers. These are words like pair and dozen. The word pair means two, but it's not a cardinal two, it's not an ordinal two, and it's not a nominal two. It's two from the idea of groupings and collections.
We're lost. Could you give us some other example?
Okay, consider the sentence. I own 5 pair of shoes, and then I own 10 shoes. Those don't mean the same thing.
Illogical. 5 multiplied by 2 is 10. Both statements convey identical information.
No,
No,
Robert, because if you say you own 10 shoes, I would assume you have a giant, chaotic pile of mismatched left and right sneakers. Or maybe you're a carton centipede. But if you say 5 pairs, you are telling me those objects are structured into functional sets. Trust me, I'm really into shoes. Like literally, I'm into shoes.
Okay, now we're on a roll. Even pair is not the full list. Consider dual. A person can have dual citizenship passport, but not pair citizenship passport. Both words mean two, and both words mean a group of size two. But yeah, that means the collective numbers here, collective numbers also have more than one kind.
Hey, we remember this when we were studying jazz music. There is a jazz duo, a jazz trio, a jazz quartet, and so on. But it can't be called a jazz pair.
And figure skating is the opposite of jazz. It's pair figure skating, but not duo figure skating.
Yes, yes. You're starting to crack it all wide open now.
What about words like double, triple, or quadruple? What property of numbers are those?
Or the
those would be
opposite. Half, third, quarter.
Third is another example of ambiguity. The third of half, third, quarter is not the same property as the third of first, second, third.
Okay, those I would probably call multiplicative or distributive numbers. But now you're starting to see properties of numbers are not just cardinal and ordinal. It is infinite. We can dream up property after property after property with just no end.
Once, twice, thrice. It's uncommon to say thrice, but it still counts.
Unary, binary, tertiary.
Simplex and triplex.
Oh, yeah, I'm so proud of you all. Yes. When schools teach properties of numbers, it's not just a mistake of teaching abstractions to very young children who aren't at the stage yet of understanding abstractions to abstractions. There's also deeply limiting factor here. It trains students to think that there are two and only two properties of numbers, when the truth is they're infinite. Let's close this up with one important property that we haven't covered. And we haven't covered it yet because it doesn't exist in English.
Wait, a language cannot just have something?
Yeah, think back to what we said at the very beginning. 5 apples is not an abstraction, it's a physical thing. But if we take away the apples and just leave 5 on its own, that is an abstraction. In English, we use the exact same word. We use the word 5 for both the real world example and the abstract concept. But not all languages do that.
So they have entirely separate words depending on whether they are touching a physical object?
Yeah, exactly. The one that I know most about is Irish. They use what's called disjunctive numbers. Let's add that on. Disjunctive. This is a specific grammar form when, it's only when a number is entirely detached from a physical thing. Like when we talked about 5 apples or 5 floors in a building. Irish would use the word ra. Ra. Okay, I can't roll my R's very well, so that pronunciation is not quite right, but it's something like ra. But when we start using abstraction, when we take away the apples, when we take away the building, we have just the idea of 5. Irish would use the word ado.
This is trippy. It's going to take us a while to wrap our mind around this.
Yeah, we should probably stop for the day. This has been a lot to take in. So let's go change over to there. Okay, I want to leave you with a sneak peek at next week. Today, we learned that schools teach cardinal and ordinal, but that's not the whole thing. Next week, we'll learn that schools teach commutative, associative, and distributive, but that's not the entire list either. Now, remember, I'm recording all of our lessons, so if you need to go back and watch it again, you can, but I'm really busy with grading papers this week, and I don't know when I'm going to be able to get around to the upload. So go to the channel, make sure you're subscribed, so when I actually do upload it, you'll get a notification. As always, if you have a question, please do not post in the comments of the video. I don't read those. If you have a question, email them directly to me. That is all for today. Goodbye, everyone.
All right.
Bye-bye.
See ya.
Goodbye.
Bye-bye.